Hello and welcome to the next episode of the Klingberg Wing Mark II development. I'm Roald Klingberg, your host. Today I'm going to talk about recent upgrades to the glider, including a little segment on optical illusions. So stick around and I hope you enjoy this segment. Welcome back. Upgrades to the glider. You might be thinking, gee, Raul, why are you doing upgrades to the glider? The darn thing hasn't even flown yet. But I got some stuff to tell you here at the end of the video that might change your mind about that, so stick around. Let's dive in and talk about some of the upgrades that I've made recently and why I've made them. Let's start with the simple stuff. Although it's difficult for you to see back here, I've this cross member here at the aft portion of the pilot's cage, and I'll put up a picture so you can see it better. I put in a new one that's further aft. It used to be about 5 inches further forward, and as we've tested the glider, we realized the pilot has to sit further aft, and I was now back to the point where my big fat butt was bumping up against the bar that was across here. There really wasn't enough room, so I cut that one off, and I extended the pilot's cage aft like this so that I could put in a new cross member back here and still have room for the wheel. So it's just essentially an extension of the pilot's cage aft. And I put in a little larger diameter cross piece for a little more structural integrity. Very simple, straightforward change. It's a little surprising to me that I'm making so many changes to the pilot's cage, because really when I built this thing at the beginning, I thought, there's so many unknowns about this glider. I'm sure that I'm going to doink it somewhere along the line during the ground testing and crush parts of the pilot's cage. I'm going to be building a new one anyway. So I wasn't too hard over about making this one perfect, but maybe I should have. I don't know. We haven't really broken it yet, except for breaking off a front wheel, which is nothing. So in that regard, we'll move on to the front end here. You might notice that if you've been watching closely in the past, this used to be much skinnier. The vertical strut at the front of the pilot's cage was 1/2 inch diameter before, and now I've taken it up to 1 inch, and not for flight integrity, but for ground handling. We discovered that when you're out in the field and you're pushing the thing back up the hill, well, you might not be pushing on the leading edge. You might be shoving on this thing. Or it came in pretty handy for picking up the nose of the glider. You can't get down low enough, so you just grab this guy and start lifting up on the nose. So this became multifunctional. It's here to protect the pilot's cage from breaking up in this direction. If you doink the nose in, it transfers the loads up into the major airframe. But really, it turns out to serve other functions also. So I upsized it. And really, this is one of the parts that I thought for sure was going to break somewhere on the ground testing, but didn't. So I just swapped it out. I had to put in a couple of new plates here to fit the wider diameter tubing. And in the process, you can't see it, but I put a little piece of plywood up here on the bottom of the wing. It turns out that these mounting plates for the front tube, they weren't touching here when it's folded up, but during transportation, it would vibrate up and down. It was poking holes in the bottom of the wing. So we patched that up, and I put a little pad there for it to bump into. Just one of those little tweaks that makes it a little bit better. So, new in back, new in front. Those of you on YouTube that don't visit Patreon, you don't know about the new lift handle. Let me see if I can get the control stick out of the way so you can see it. I'll put up a picture of this also. I've put in a new handle on this side, and if I get around back here and I can reach up here, this is to help with the ground handling, so that you can grab on here, and with the angle and the top grip, it just gives you a much more solid grip than grabbing the bottom of the cage like this. And it actually changed the vectors on the forces. When you grab just the bottom like this, I got my hand on the stick and I got this horizontal tube. When you went to lift, it would also impart a rolling moment on it. And I haven't sat down to sketch out all the vectors, but for some reason, putting on this hand grip on the side prevented that rolling motion. Now I can get a nice clean lift up. I can go tail first and then nose or straight up, and that gives me a much more solid grip on the glider for adjusting pitch up and down. In other words, I can get one hand on the stick here, grip it down low, and a hand over there, and I have much better pitch control during the ground handling. So that's a big plus. I got it on here with a couple little hose clamps. I got them loose right now. When we fold up the pilot's cage, it just folds down flat like that. You fold up the pilot's cage. So it's another step. You got a couple of screws to tighten when it's up in place. And because we've moved the pilot aft, the flap handle got a little far away. It was up in here. You could only reach it when you were in flight mode, semi-reclined, and it obviously needs to be available during the launch sequence. So I moved that back 5 inches with a little easier grip. It's easy to reach this hand grip, so it's easy to reach the flap handle now. And that was just lengthening the rope, no big deal. So those are pretty much the minor ones. Let's move up to a more significant one. Previously, we used to route the control cables through these 2 holes in the root rib and 2 holes on the other side. They went inside, went over some pulleys, and came out here, and the cables would come down, and we'd clip them onto the control horns of the gearbox down here, the mixer. And it wasn't too bad. On some of them, I had to use a wire fed through there with a hook on the end to pull them through, made it a little easier. It was difficult taking them out. Sometimes they get jammed sideways. It was a little problematic, but the biggest problem was when you were putting the wing on the glider, you had to get the wing up on your hip and hold it like this in the most awkward way while you're trying to feed the cables into those holes. It was just a nightmare that way. It really required an acrobat to be able to do it. And then worst of all, you get very close to fitting in the wing to find a little distance to go putting the wing in. And I tell the guy on the tip, push, and I thought the cables would usually feed in straight, but not always, and sometimes the cable would flex down, and boom, the cable would get pinched in between the main wing panel and the center section. You put a kink in the cable, very bad. So just too problematic. So now, and I'll put up a picture here, I'm running the cables out the bottom of the surface of the wing, right at the attachment point here, and they line up with this pulley block that I put on the bottom of the wing. And the cables from the pulley block are permanently attached now to the control horns on the mixer. And the control connections are up here overhead. So when the cables come from the main wing panels, they clip in up here overhead where it's nice and easy to do it. So no more going through, easier to hook up the cables. Probably when we ran into problems taking it apart, it would add 5 minutes or more to the disassembly time. And this will save a lot of time. Let me get the flap control horn out of the way. Now, you might be wondering about, oh, you got a big honking thing hanging in here in the breeze, and I see you got some kind of dam here to stop the wind, and that this piece of wood here is to actually keep the connectors separated so that they don't bind up against each other. But in actuality, there will be a windscreen that wraps around the front end of this thing, and there'll be side panels here. So eventually, all of this stuff, all of the components up here that are all very draggy are going to get closed off. So anything that I added here is a non-issue. And I just essentially bonded this to the bottom surface of the wing and then fiberglassed it in place. It's not going anywhere. Now that added about 4 ounces to the weight of the aircraft, 4 plus a little. And unfortunately, I didn't want to cut open the wing. Unfortunately, I could not take out the old pulleys. They're inside the wing. I didn't want to cut the skins, so that weight just stays in there. Otherwise, it would have been an even swap. This might actually be a little lighter, might be about an ounce lighter because of all of the guideways and so forth for the pulleys that are inside the wing. So, but in terms of assembly and disassembly, it's a definite plus up. And speaking of assembly and disassembly, let's see, I dropped something on the ground here. Let's get that. Oh, okay, the wing pins. You might, let me get a little closer to the camera so you can see these. These are the original wing pins, one of them. And you'll notice that there are 2 pieces of titanium tubing. Get it up in view there. 2 pieces of titanium tubing bonded onto a piece of aluminum tubing as a carrier. And the clevis arrangements would come on those pins like that, and that's what held the wings on. And very lightweight, very strong, and a slick setup, except for one minor problem. There's always the unseen, the things that you just can't imagine would happen. So as you know, there are two clevis arrangements on each wing that the pin holds together. So what would happen going in was easy. Well, you got a little tapered end here, and you wiggle it around, and boom, boom, and then it goes. It really wasn't that big of a problem. Taking it out, however. So what you have to do when you take these out is you have to unload the wing. So you got somebody out on the wingtip, or you got a wing stooge, and you carry the weight of the wing, and so that you can slide the pin out. Well, as soon as this lower one would come out of the clevis fittings, boom, it would jump over to the side. The upper clevis fittings would be allowed to shift because they're now down here on the narrower portion, the aluminum tube. So this guy's out, and this guy is out of its clevis, and now the clevis is wrapped around the smaller tube. Oh, and then you'd have to fiddle around, pushing in, pulling it back as you get up and get the second tube up through the upper clevis. And you could wiggle around for 2-3 minutes trying to get it out of there, and wiggling this and probably putting too many loads on the system. And it was very lightweight, but not that functional. So what I did is I just, as with many aircraft, the solution is spend more money. So I bought titanium tubes that are full length, no change in diameter. And in the process, I was able to actually reduce the wall thickness of the titanium tube. Those were oversized, way stronger than they needed to be. So I reduced the wall thickness by about 25%. And it's now just a straight tube with a tapered end on it. And this baby slides in, and when you take the weight out, it just slides right out, and you don't have any misalignment of the parts on the way out. And it's just one straight pull to get it out. It's much quicker, easier, straightforward. Cost a little bit more money, but that's life with aircraft. If you have to ask, you really shouldn't be in the sport. And the other issue is that it's a little harder to work with and build, and it added a little weight. It added about 2 ounces, so we just have to suck that up to make our lives easier when it comes to assembly and disassembly, but a plus overall. And let's see. As you've probably noticed, I'm wearing this lovely garment here. This is actually the new lift harness. You remember the old lift harness had a couple purple padded straps that went over my shoulder and some other accoutrement, and it had actually 2 connection points on it. It had one on the front straps here that went down forward to the pilot's cage, had 2 in back up near my shoulders that went down to the pilot's cage aft of me. In other words, 4 attachment points total. With all the ground handling that we've done, I came to the conclusion that despite the fact that I was kind of copying the Swift solution and figured what worked for them would work for me, really wasn't working on this aircraft. That 4-point attachment system on the pilot's cage prevented me from being able to accurately control the pitch angle of the glider at launch. And as I'm going to tell you in a minute here, you stick with me, I'm going to tell you about this optical illusion and why it becomes very important with this aircraft to have very precise control over the pitch at launch. But anyway, so I bought this off of Amazon, and it's a tool harness. And I sewed on a couple of clips here to clip in, and now I clip in at 2 points. And those 2 points are right here just aft of the vertical struts for the pilot's cage. And the reason they're back here is because that is just slightly aft of the empty center of gravity. The empty center of gravity is right here. So it's a few inches behind the empty center of gravity. And as we experienced in the early ground tests, I had a tendency to, when I'd rotate, get the aircraft up off the ground or off the sawhorses, I would bring the nose up like this and stall the wing. And that was causing all kinds of problems. And I felt that part of that issue was most of the weight's further aft. There's like 70 pounds on the rear wheel and 11, 12 pounds on the front wheel, or excuse me, 30, 31 pounds on the front wheel, 34 or something like that. And so it's just a natural tendency that the lighter area, that's just going to come up first. And with a 4-point suspension system on the harness, depending upon where those were positioned, both front and rear, would cause you to either lift nose first or tail first, and there wasn't much you could do about it. And then once you had it up, because of a 4-point system, it was very hard to adjust the pitch of the aircraft up and down. It was pretty much determined by how the harness was set up. And there wasn't much I could do about it, you know, where I didn't have to just really pull down on the harness to allow enough slack or pull up, whatever I needed to do. So now, with 2 attachment points back here, there's an axis that it pivots on. You could just run an imaginary line through those 2 points, and now I have an axis to pivot about. Very easy to pitch the glider up and down and make pitch adjustments. And it's just so much easier to handle. So what happens here is, with these 2 hooked in behind me, these go aft and hook in here. When I lift, I am lifting behind the center of gravity. These 2 points behind the center of gravity. So when I lift, the back end comes up first. So you're coming up in a nose down configuration, which for this aircraft actually turns out to be superior solution. Because as I lift and it's nose down like this, all I have to do is feed in a little bit of up elevator and up comes the nose. And not only that, if the breeze is blowing at all, 6 miles an hour, 7 miles an hour, I can find that balance point perfectly with the elevator and make sure that the center of gravity doesn't get behind me. And I'll tell you in a minute why that's really bad. I avoid stalling the wing because I have control of it, because I'm not overshooting and stalling the wing when I first lift it. And once the wing is stalled and you're got 5 mile an hour breeze or 10 mile an hour breeze, very difficult to get the nose back down, especially with that 4-point lift harness suspension system. So this is a big plus. This allows me to lift the tail first and fly the nose up into appropriate angled attack. And the worst part of it all, the old harness, was quite often you get the CG, the empty CG of the glider is way up here. My head is at the same point, so I'm like right here. So the center of gravity is directly over my head like this. And as soon as the center of gravity goes behind you, whoa, it feels like you're getting blown back. And it's like, it really feels like the wind's caught the wing and it's blowing 20 miles an hour and it's just dragging you back. But actually what it is, it's like the upside down broom on your hand kind of thing, or any standard rocket launch, is that the center of gravity got too far off axis. And let me tell you, once it's behind you, very hard to get back forward. Just because of the way that we're built. We bend to the waist like this. If you have the center of gravity in front of you, if it gets in front of your head, well, it's pretty easy to lean back and recover that. But once it's behind you, and especially behind your heels, you lose your balance, you start staggering backwards. It's just a terrible situation to get that center of gravity behind you. This all helps prevent that. And it is so much better. And I've had it out, we've tried it, and it works great. So, now, I'm just about to get down to the Optical Illusion, and you're going to find it very interesting, so stick around a bit, and I'll tell you a little bit more about the last test that we did when I was out. We didn't shoot any video, sorry about that, but when we had it out, with the new harness, the side grip, and I adjusted the amount of throw on the elevators, and you can't, maybe you can see it here. There's the control horn here that runs the elevators up and down. I biased that to one side. Instead of splitting it even in the middle and having to even throw both ways, I can slide a gear off here and turn it a few teeth back. I've set it up now so that it has less down elevator and more up. And that has to do with the arc that it swings on. When you set the control horn further aft like this, well, it's got a much more linear sweep going forward than it has linear sweep going back. The linear rapidly turns to vertical, so you don't get as much down elevator throw as up elevator. And that's a plus in many ways, because we've had problems with stalling the elevator, getting ready to take off, getting set up to take off, and this helps prevent that, combined along with the harness and so forth. So when we were out for this testing, unfortunately, we were out on the Memorial Day weekend. The winds were good, and boy, the handling was perfect. I can pick up the wing and walk around with it. I don't need any extra help like I did before. Oh, Peter was always there ready to grab something in case I start blowing sideways or get tilted over backwards. But no, I had very precise control over it. Wind was blowing about 9-10 miles an hour, and I'm just flying the glider in place. It's carrying some of the weight, and I could feel that balance because of this 2-point suspension system. Very easy to feel it on the stick. I could feel it overhead. And it's like, oh, here it comes. Oh, I'm on the spot. Okay, right there. Oh, getting a little too far aft, doing a little down elevator. It was so much better. And we combined that with another change. We took the flight harness, which I'm not wearing right now, and had it hooked in here on the pilot's cage, right where we want the center of gravity to be when I'm flying. And I wanted to see what that was like with maneuverability on the ground and so forth, compared to hooking in overhead. And I think it's actually superior. Now, the drawback to this setup for my particular glider, this pilot's cage is not designed to take 6 G's of load of my weight hanging from here. These tubes would crush and be all done. This was meant for ground handling loads only, and my weight was to be transferred into these significant structural members overhead. We still have more testing to do, but it looks like hooking in overhead makes the straps going up here and just the way that it's set up makes launch a little harder. And this appears to make it a little easier. So it might be a case where I'm going to end up building a new pilot's cage just for structural reasons, not because I destroyed this one. So that was a plus too. So there we are, we're at the beach, we got all of these pluses, and it's handling nice, and we could have easily taken it for a first flight. It really was ready to fly. This glider is ready to fly. It is flyable. It will fly. But the beach was littered with people. And that lifeguard station that you've seen in other pictures. And as my buddy Bob pointed out, he says, you know, dodging people and a lifeguard station on your first test flight is probably not a good idea. So not only is it not a good idea, it's a really, really bad idea. So we just made a couple of ground runs there and repeated tests that we've done in the past. It says, oh yeah, handling's great, she's ready to fly. I took it so that it was lifting maybe a third of my weight, maybe a little bit more. She really is ready to go, but we just couldn't do it because there were too many people there. So you might be, that's the reason for the upgrades. I wouldn't go do all these upgrades and spend this money if I didn't have very high confidence that this glider is ready to go, ready to fly. I think next time we go out, 95% chance that we're going to have a couple of very nice ground hops, little short hops with it. In fact, that was supposed to be tomorrow, but we've been thwarted by weather once again and a couple other issues, so we're just sitting tight. We're going to try to find 2 flyable days during the middle of the week when there won't be nearly as many people there, and then we'll get those flights in. So now, to the Optical Illusion. You're going to love this one. And I'm going to flip you around here because I'm actually going to climb in to the cockpit, and I'll bring you back in a second. Okay, so here I am in the normal takeoff position. Let's see, I'd be right about here. And with the helmet on, I'm a little underneath like this. So here's my hand on this side, right? Flap handles in easy reach. Got my grip here, got my stick. And this is really a nice setup now. I'd actually be more back in here. And we got this guy, yeah, that's about right. Pretty much my hips are right where the post is. Now, this is pretty handy because you get both elbows locked into the verticals here, and that really helps steer the yaw and help stabilize the wing. And get a good grip on the stick and a good grip over here, we're good to go. So, you may have seen a video where I did a single-handed assembly. I just wanted to do a video that shows it is possible with a complex aircraft like this, with an unusual assembly sequence, for one person to do it. You have a couple of wing stooges, and you can do it by yourself in a relatively short period of time, 20 minutes, give or take a little. And I went over to the local park to do that, and I set it up on sawhorses like this and put it together. And you can go watch that video. I'll put a link at the end here. But anyway, so I got it all set up at the park, and I'm on the sawhorse, and I go to lift it the first time with this new lifting harness, and it lifts from the rear, just like I expect, right? And then I look, and I'm watching, I lift, and up it comes, and I look forward, and then I begin adjusting my pitch angle. I pull on the stick and the side grip here to bring the nose up where I want it. And I happened to look down, and I noticed that the front of the pilot's cage was much, and we're out of balance here, it was much higher up off of the sawhorse than the rear one. The rear one was up a little, the front one's way up in the air. It's like, whoa, wait a minute. I know the pilot's cage is parallel to the chord line of the wing up here. These two are parallel to each other, chord line and the horizontal here. It's like, but I have the wing horizontal. I put the nose where I want it, it's horizontal, but the nose of the pilot cage is pointed up, and it makes no sense. The geometries don't work that way. Like, what the heck is going on? I set it back down and repeated it. Same thing happens again. It's like, wow, I must be pointing the wing a lot higher than I think. I think I have the wing horizontal, but I don't. And when that got through my thick skull, I put the pilot's cage back down so it was equidistant from the two sawhorses. Oh, and the wing was much easier to handle. It's like, oh, the CG's overhead. And it's like, oh, I kind of like this. But my God, the nose is practically pointed down at the ground. What the heck is going on? And I did a couple other things. It took a few beats, and then the little light bulb went on. I went, uh-oh. Look, here. Cord line of the wing. Bottom of the wing is angled down. This is a semi-symmetrical airfoil. The bottom is sloped down. The top is sloped up. Every other hang glider on the planet, including the Swift and the Aerooptics, they have airfoils that are flat on the bottom. And when your head's back here, your eyeballs are up here, and you're looking this way, and all I see is the nose plate. And I end up accidentally picking up a sight line that runs down the lower surface of the wing. In other words, my sight line, what I think is looking horizontal, is not. It's looking downhill at 4.4 degrees. So I was rotating the nose by 4 or 5 degrees all the time. Like, wow, what a stunning revelation. That this optical illusion that, oh, I get the bottom of the wing correct, which I wasn't even thinking about it. You're a pilot for 50 years, and you point the nose where you think you need it to be, but I'm not looking at the nose here. I'm looking at the bottom of the wing. That's 4.4 degrees different. Oh, so visually, it looks like you're pointed down at the ground, but you're not. The wing's actually level. So it's just an illusion that occurs because of the airfoil that I selected. My original wing had the same airfoil, but that was down here at my waist. So you didn't see any of this. It wasn't in your line of view. In fact, what happens with this one is, when you're launching, you never see the horizon, which is another big thing for a pilot. Normally, you're aligning your nose with the horizon, but here you can't see the horizon at all. So when I got to the beach, and I did what I knew to be correct from my practice in the park, oh gosh, look, I felt like I was pointed straight down at the shoreline where the water meets the sand. I only had maybe 2 or 3 inches visually between the bottom of the wing and where the ocean was coming in at the beach. It felt like I was pointed way downhill, but the glider handled beautifully. It was at the right angle of attack. I'm flying it, felt comfortable, and it just an optical illusion that takes a little bit of retraining of the muscle memory, the brain memory of this aircraft's different. It has to be pointed differently. It's going to look different when I launch it. So there's a learning curve involved in handling this glider, and previous experiences with other gliders really doesn't apply much. You have to realize that you're sighting along a line that's pointed down at the ground. And then if you're on a slope, well, you got to point it even further down. So it's a bit of a change, a bit of an adjustment, but once it clicks in your brain, it's like, oh, okay, I just need to point it down, and then you can feel the balance point with a stick, much better shape, no more stalling of the wing, no more stalling of the elevons, and a huge, huge plus. So now I've both made adjustments to the glider in terms of the weight and balance so that it's ready to fly, and I've made adjustments to my brain, and I've actually learned how this glider needs to be handled to foot launch it. And of course, foot launching one of these gliders is a big deal. Nobody has ever foot launched a 15-meter span sailplane. There was one that was, I'll see if I can find a picture of it, that Moyes did, 15-meter, and they foot launched it off the beach, or they more yanked them off the beach, but it was done with towing. And the 15-meter parental wing, that was towed off of the ground. I don't know anybody that's actually run down a hill with 15-meter wingspan and launched it. And that's one of my major objectives with this project, is to prove that that can be done. And the day that I launch this will be the day that we prove it's possible to run down a hill and launch a standard class sailplane. And I got my fingers crossed that I actually make that come true. So that's why I'm kind of hard over on how do I do this? How do I actually learn and set this up so that you can launch a glider by running down the hill that is of this size? And there's a lot of differences from what we currently fly. But we're getting closer all the time. And once I achieve that goal, then we can just, everybody put that in their pocket and say, here, Rawls learned all the little things that you need to do to be able to launch a sailplane of this size by foot launching. The last little thing that I did, I'll put up a picture here, is I've changed the elevon seals a little bit. The fiber seals work really good. we had very good airflow over the wing when we were out testing last night, very smooth. There's a little extra drag in the control system due to those fabric seals. So I thought that on one of the wings I would remove the fabric seal from the lower surface and replace that with a Mylar strip. I'll put up a little picture here of that. And the Mylar strip doesn't impact the drag in the control system at all. And if that wing is well behaved as the other wing, which has the fabric seals top and bottom, then I'll just switch to the Mylar seals and remove that drag out of the system, and we'll be happy. We'll have those gaps sealed off like we want them to be. So that's about all for today. I would say that if you enjoy this series, if you're enjoying my channel, and you want to help out and be a bigger part of the scene and get some of the inside knowledge and get it early, you go over to Patreon. All my patrons get all of this information weeks before you get it on YouTube, and they get extra technical information also. So if you have a mind to, you go over to Patreon and you become a patron, and I'll be eternally grateful, because we have a lot of costs coming associated with the flight testing, and extra support for that will be most welcome. So until then, as I always say, fly safe and bye for now.